Oh, great, mixed numbers. Okay, I am not a fan of mixed numbers, but we are going to go ahead and use them anyway because the fact of the matter is mixed numbers are more practical, right? If you hear the number 17 over 2, it just doesn't sound the same as 8.5, which it is. So, writing mixed numbers, and there's that word improper again. Not a big fan of it, but here we go anyway. Write 2 7/8 as an improper fraction. Okay, so we are going to go ahead really fast and do this visually once or twice. Then we're just going to go ahead and do it mathematically going forward. Remember, you can always fall back onto the visuals if you need to, but it's probably a better idea to get used to doing them without needing to. So we've got 2 7/8. We're going to go ahead and go back to pizza. We've got 1, 2, 3 pizzas. You'll see why in a second. And each pizza is cut into 8 pieces, right? That's what the denominator does. It tells you what the denomination of the pieces are. So we're going to cut it in half, and in half, and in half, and in half. That gives us 1, 2, 3, 4, 5, 6, 7, 8 pieces. We'll do that to all 3 of these. Okay, now we already know we have 2 full pizzas, right? So we've got 1, 2, 3, 4, 5, 6, 7, 8 pieces here, and then 9, 10, 11, 12, 13, 14, 15, 16 pieces here. So instead of saying 2 7/8, which by the way is the same as 2 plus 7/8, right? When you say 2 7/8, the word and almost always in math means plus or minus. It usually means combining in that way. So instead of 2, since we've cut those 2 pieces into 8 pieces each, or pizzas into 8 pieces each, we could instead call this 16/8 instead of 2. Boom, boom, boom. There's my 2 whole pizzas, which is right here. But since it's cut into 8ths, that means that there are actually 16 pieces plus another 7 pieces. 1, 2, 3, 4, 5, 6, 7. So our grand total is going to be 16, 17, 18, 19, 20, 21, 22, 23, 23, and each piece is 1/8, so we have 23/8 pizzas. Now, mathematically, let's talk a little bit about what we just did. We took 2 over 1 plus 7 over 8, and we converted it into 16 over 8, right? So mathematically what we did is we recognized that to get a common denominator, well, what's a number I could multiply? The denominator is 8, so I'm going to multiply by 8 for the reasons that we talked about earlier in a previous video. We're really just multiplying by 1, right? 8 divided by 8 is 1. You're allowed to multiply it by 1. It doesn't change the value at all, but it does change the way it looks. That 2 on the top times 8 becomes 16. That 1 on the bottom times 8 becomes 8. And again, I think you already know that 16 divided by 8 is indeed 2, right? They are the same value. We are just sort of unsimplifying the fraction so that it has the same denomination, the same denominator as the other fraction, so that all the pieces are 1/8 of a pizza. We've got 23 over 8. Write 29 over 5 as a mixed number. Okay, so there are a bunch of ways that we can do this. I will go ahead and choose one at random, and we'll do a few different ways. Okay, 29/5. Well, let's see. One way you could think of it is, what is the biggest multiple of 5 that fits into 29? Yeah, what's the biggest multiple of 5? Well, let's see. 5, 10, 15, 20, 25, 30 is too big. So it looks like there are 5 groups of 5 up there. So we could call this, we could decompose this into 25 fifths plus 4 fifths. Yes? 25 fifths plus 4 fifths is indeed 26, 27, 28, 29, 29 fifths. But we already know that 29 or 25 over 5 is 5, right? 25 divided by 5 is 5. If I have 25 things split into 5 groups evenly, each group has 5 in it, my total answer is 5 and 4 fifths, which again, I get why that's a little bit easier to wrap your head around other than 29 fifths, which is a little bit weird, right? 5 and 4 fifths at least tells you that you're between 5 and 6 on the number line and that you're closer to 6 than 5. So the answer is 5 and 4 fifths. Now, to make mixed numbers in Khan Academy, you hit 4, then you hit a space. I'm sorry, you hit 5, space, what did I just say? 4 fifths. Write 2 and 1/3 as an improper fraction. Okay, so now we're going to do it a little bit of a different way. Here's the way I learned it, okay? Here's the way I learned it, and this is kind of a cheap trick, but if you know why the cheap trick works, then it is totally valid. Here's what I was taught. I was taught to multiply the whole number times the denominator, so 2 times 3 is 6, and then add it to the numerator. 1 plus 6 is 7/3, okay? Like I said, it's a cheap shortcut, but let's talk about why it works, okay? What am I actually multiplying? This is actually 2 over 1 plus 1 over 3, yeah? 2 is the same thing as 2 over 1. Every whole number is a fraction. If you take it and put it divided by 1, every whole number is also a fraction, right? So if we want a common denominator, if we want a number that is the same on the bottom, well, I can get that by multiplying the top and the bottom of that fraction times 3. Again, using the denominator of the other fraction to get us to a place where we've got a denominator in common. 1 times 3 on the bottom is 3. 2 times 3 on the top is 6. We get 6/3 plus 1/3. 6 and 1 is 7. So indeed, we do get 7/3. So if this helps you, if this shortcut is good for you, use it, but remember that you may have to explain to your teacher or whoever why it is that you're doing what you're doing. These kind of shortcuts are fine, but you can't use them as a substitute for understanding the patterns. This is about cutting pizzas into smaller pieces, not about memorizing a procedure that allows you to get the right answer as fast as possible. That's not what math is about. Not anymore, anyway. It was back in my day and my parents' day. 7/3. Write 7/3 as a mixed number. Okay, so continuing with my pattern of doing things in different ways, okay? Let's do 7 divided by 3, right? I do keep saying that fractions and division are the same thing, and we have seen this kind of division before, right? How many times does 3 go into 7? Well, let's see. 3, 6, 7, 8, 9 is too many, so it goes in twice with a remainder of 1 left over, yeah? Go back to previous videos if you need to remember that. So we've got 2 with a remainder of 1, but that 1 is 1/7. Yeah, because we're still dividing, right? What we're saying is that 7 divided by 3, sorry, I always get it mixed up on that long division, is the same thing as 2 plus the remainder 1, which is still being divided by 7. Sorry about the little bit of uncentering there. There we go. Which is the same thing as 2 and 1/7. So that's another way even that you can look at it. All of these are the same thing. You may have learned one of these ways. You may have learned another way that's completely different. You may have learned the butterfly method, which I will absolutely talk about at some point in the future. All of these methods mean the same thing. You are trying to get the denominators to match so that you can count up, or in this case, you are trying to find the largest whole number as possible, pull it out, and find out what your remainder is. So we got 2 and 1/3. 3 more. Okay, we've got 7 and 9/10. Again, I want to get the same denominator. I can multiply 1 by 10. So that actually gives me 70 over 10 plus 9 over 10 equals 79 over 10. It's all just multiplication. It's scaling, essentially. Write 14 over 5 as a mixed number. Well, the biggest multiple of 5 that I can pull out of 14. 5, 10, 15 is too big, so I can take 10 out of 5. That's the biggest multiple of 5, plus 4 over 5. Well, I know what 10 over 5 is, right? 10 over 5 is 2. And then the other 4/5 just stays 4/5. So 14 over 5 is the same thing as 2 and 4/5. One more. Write 3 and 5/6 as an improper fraction. Okay, well, once again, it's actually really easy to find a common denominator when one of them has a denominator of 1, right? Just multiply it by the other denominator. Don't forget that you're doing it on the top and the bottom, right? You are cutting up both the pieces that you have and the total number of pieces that each pizza is being cut into. So we get 18 over 6 plus 5 over 6. And now we're back to counting on our fingers. 19, 20, 21, 22, 23 over 6. Hopefully no problem at this point, but you never know. This does take a long time for a lot of folks. Now again, personally, 23 over 6. Another way you could think of it is that 4 is 24 over 6, and this is just 1/6 less. Again, I tend to mathematically believe that these improper fractions, as they're called, are a lot easier to work with than mixed numbers. In fact, normally, if you're going to be adding or subtracting or multiplying or dividing mixed numbers, the most efficient way is usually, not always, but usually to make them into 2 fractions and then deal with them. Sometimes I suppose you could like add just the whole parts together and then mess with just the fractions, but that gets really complicated when you start multiplying especially. And that's right, mixed numbers and improper fractions. We are moving right along. What do we got next?